Solve the revolution. Hey, it's a topic that we know. So the calculator may be required for the following problems. Let R be the region enclosed by the graphs f of x equals e to the x and g of x equals 3 minus x squared as shown above in the figure. Find the area. You tell me. This is absolutely essential, folks. Got to know how to do this. This is number one. So I want to find the area of R. Tell me anything. Yes. Top minus bottom. Which function is on the top? Yep, g of x is on the top. Excellent. Which function is on the bottom? F of x. Great. So let's go ahead, and as she said top minus bottom, I will do integral of the top, which is g of x, minus the bottom, which is f of x dx. What am I missing? Bounds. How would you go about finding your bounds? Excellent. Love it. I'm going to turn this on, and I go into y equals. Clear that out. I get e to the x. And I get, what? 3 minus x squared. I'm going to zoom standard. And we can see the region right there. So I want to find those intersection points. What do I press? And I grab number 5. And it asks me the first curve. I'm going to move closer to my intersection point. And just, it doesn't matter which one you say is the first curve, so long as when it says second curve, you see it jumps to the other one. And I'll press enter on guess. And I'm going to call that coordinate A. And I'm going to say A is equal to negative 1.677233. Yep. I just moved closer to that intersection point. I'll do it again. Second, calculate, intersect number 5. And I move over to the right. And I get this coordinate right there, which is B equals 0.83448687. So I'm going to put the bounds from A to B. So you could go ahead and use your variables instead of retyping the whole piece. Question? I would say go at least to the third. I tend to write them all out because they want your answer accurate to the third decimal place. So I just write them all out. And I just shorthand it the rest of the way. So g of x minus f of x. And so it looks like g of x is my y sub 2. And then e of x is, see, I'm going to write this down because otherwise I get confused here. Let's say g of x was the y sub 2. And then f of x is the y sub 1. Okay, so now I know what to do. All right, so I've got them typed in. So I want to do this integral. And you could either type it all in, or you could simply do y sub 2 minus y sub 1. Who knows how to do y sub 2 minus y sub 1 on your calculator? Bars. Y bars. Enter on function. Y2. Minus. Bars. Y bars. Function Y1. So you can see now that I'm set up to do this calculation. If you wanted to retype everything in, you can, but I'm just going to take the highlighted portion off of that. And I'm just going to calculate the integral of that y2 minus y1. Henrik, you got that sheet? Nope, that's the other one. Is there any question about where we're at so far? Okay, so let's second calculate number 7. And let's find that area. And I'm going to type it for my lower limit, the negative 1.677233. And for my upper limit, I'm going to type in 0.83448,687. And I get, and they want this, so this is the rule for AP. This is what they'll accept. 3.651 or 3.652. So either just cut off after the third or round to the closest third place. Either one they would accept. Do you see that? So that's why I typed in all of those, because I wanted my final answer to be right to that. I haven't gone through and figured out, you know, what I have to do in order to make that happen. Any question? Can you do that problem on the test? And you guys, I want to be clear for like teachers who might be watching right now, because like, hey, I need some good AP review. They're saying, oh yeah, that's like one of the most common types of questions that are asked on the AP exam. Okay, you're wondering what the free response is. Everything we do right now is an excellent example of free response. That would be 3 points right there out of 9. You do that, you get 3 out of 9. Find the volume when R is rotated about the horizontal line, y equals 4. So I'm going to rotate this region that is in yellow. I'm going to rotate that about y equals 4. So that's 2, 3, 4. So I'm going to rotate it about there. Anybody? Thoughts? Washer, excellent. Does everybody see that you were going to get a washer? Okay, so we want to write it out. Again, we've got 15 minutes on this problem, so it's about 5 minutes per section. I know it feels like we're taking a long time, but trust me, we're doing pretty good. So I'm going to draw this out. And I'm going to draw these sections here, and then here, and then on the bottom. All right, what makes the middle? Y equals 4. What's the thickness, dy or dx? Dx, very good. Horizontal thickness. What makes up this middle part right here? Yeah, and we'll call that, that's 3 minus x squared, that's our g of x, right? G of x. And then what makes up the bottom? F of x. So what's our formula for a washer? Pi times big R squared minus little r squared. Good. So how do we determine the large radius? Top minus bottom. So what would that be? 4 minus f of x. So 4 minus f of x, that's equal to big R. So what's little r? This is what you did wrong on the test. Good. 4 minus g of x. A lot of people did g of x minus f of x. See the difference between 4 minus g of x, folks? That's your little radius. 4 minus g of x. Good. So I have my big R, I have my little r. So it says find the volume. We got pi times big R squared, which is 4 minus f of x squared, minus little r, 4 minus g of x squared dx. And we're going to integrate from what to what? A to b. So I don't know about you, but I feel like I would make more mistakes if I were to actually plug in the functions there. You know what I mean? So now we need to evaluate that. You're not going to do that by hand. You can see why you have the calculator problem. So I'm going to go straight to this guy right here. I'm going to go into my y equals. I can see that my f of x function is, which one's f of x again? F of x was the e to the x. Okay, so that was the e to the x one. I just need to label it so I don't mess it up. And then y sub 2 is was the g of x one. So I'm sorry, so this was the y sub 1 and this is the y sub 2. Okay. All right. Sorry about that. So we're going to type that in. I know it looks crazy, but we're going to type that in. So parentheses 4 minus what? Did I switch them up? Okay, so I'm going to go 4 minus e to the x, or just y1, right? So I'm going to go vars, y vars, function, y1. Parentheses, and what do I do with that? Square it. Minus, parentheses, 4 minus what? Y sub 2. What do I do with that? Square it. And so we're going to second calculate number 7. And I'm going to grab my bounds. I go from negative 1.677233 up to 0.83448687. And we get 17.109. What do you think? Yes, it's wrong. Yep, this is wrong. Yep, that's my most common mistake that I make. I'm like, shoot, I forgot the pi, and then I don't get my score I want. Got to put pi there. If you want to multiply the pi out, that's fine. Just make sure it's either multiplied or you include it. We good? Okay. This is the new part. Don't get mad at me. It's a lot worse. No, it's a lot better than what it looks like. See that? See how I did that? See, I was going to say it's a lot worse than what it looks like. Because it's not going to look very good, but we're going to make it really good. It says region R is the base of a solid. And for the solid at each x, the cross-section perpendicular to the x-axis is a square. Find the volume of the solid. Oh my goodness. Sounds ridiculous, doesn't it? Can we help you try to make sense out of this in a reasonable manner? This is going to require you guys to really visualize, okay? So this is a lot of times kind of a third part of the free response that they ask. Is everybody okay with me saying that this purple spot here is my region that I'm working with? They're saying that there's a solid, so a three-dimensional figure, and this is the bottom. And it has shape to it. Like if you were to slice it, like let's say that this was like, I don't know, like bread, and you were to slice it, you get like square slices that would come on off, okay? And I want you guys to see if you could tell me, is the square that's going to come on out, is it bigger on right there, or is it going to be bigger right here? Is it going to be bigger on the left one or the right one? The right one, yeah. If you actually looked at the slice of bread that you got off from that, if you were going to kind of cut it, it would be like that tall. And then this shape right there, it would be significantly larger. Okay, so it's hard to, I can't draw it so that you can see it, but it's this thing that's coming out of the board at us. And it looks really complicated, but here's the idea. Do you know how to find the volume or the area of a square? Then you can do the problem. Okay? Watch how easy we're going to make this. This square that comes out at us, okay? It has dimensions. Tell me something about a square. All sides are equal. So, all we want to do is find the volume of this shape right here. Notice how the thickness is still dx. Can somebody tell me what this, if we can find one dimension, we know all the dimensions, right? What's this dimension right here? Yeah, Look at what he said. He said this dimension right here is just the top one minus the bottom one, right? So, and that would be, what's our top function? It's g of x. So we have g of x minus f of x. So what's the other side going to be? G of x minus f of x. So that means that the volume of one of these things is going to be those two multiplied together, right? So g of x minus f of x, yes, the area are those two multiplied together, or squared, right? Volume, we attach the d of x, or dx. We don't want one of them, we want an infinite number. So you just slap on an integral, and we go from a to b. Now, we said again that g of x is the 3 minus x squared. So that's my y sub 2. So it's a y sub 2 minus y sub 1 I've got going on here. So I'm going to go ahead and I'm going to go to my y equals. I'm going to type that in one more time. Y equals. And I've got to type, whoop, don't do that, Mr. Gentz. I'm going to go down here. I'm going to type in parentheses. G of x, which is y sub 2, so vars, y vars, function, y sub 2 minus y sub 1. Ooh, I've got it right there, squared, cool. And I'm going to take off my equal sign up here. And I'm going to second calculate, and I'm going to do number 7. And can somebody read off my bounds for me again? I'm going from what? Negative 1.67. Okay. And then my upper bound is going to be 0.8683. And it's going to do that computation, and I have 6.358. And we pause. That's one type of free response question. Generally during class, we only have time to get 2 done. I want you to pair and share with somebody, and I want you to tell me which one of these things do you think you would get, and which one do you think you would not get. Go ahead, talk. Shh. Okay. Somebody tell me, which parts do you think you could get? You think you could do both A and B? So if you do A and B, you're going to be getting 6 points. And that's good. So usually our average as a class is right around that 2 to 3 range. And I would argue that we could get 6 points on this. And I think that the washer problem that I gave you, I think that that's on the more challenging side for what they would give, because we're rotating it up. Most times it's rotated down. Notice they could give you a dy problem. We gave you the dx. That would make it more complicated. And letter C, as you see it, you're kind of like, well, I don't think I would probably get that as much, right? Is that where most people are at? But if you were to practice it a couple times, maybe you have a better shot. And maybe you wouldn't get all of the points, but maybe you could get like, maybe you get all 3 here, and maybe you get like 2 here and 1 there or something like that. So they break it up into parts for you, but can you understand that for my expectations as a teacher, I think we can avoid the 2, don't you? Like, I think that that's reasonable, okay? I really do. Flip it over. Okay, once again, you're going to get 6 problems on your free response. The first 2 are going to allow a calculator, the other 4 are not. So what does one of these problems look like if you are not allowed to use a calculator? Let's check it out. You have 2 functions here. It says f of x is sine of x and g of x is x minus pi. Tell me which one's on top, f or g? F is on top, we'll call that y1, and what is on bottom? It is g, we'll call that y2. The question asks, find the area of R. So we're trying to find this area right here. This is a non-calculator section. That's what we're trying to determine. Somebody please set up for me the integral. F of x minus g of x, so sine of x minus x plus pi. I think you might have written minus pi, possibly. Everybody see why I have plus pi? I have to distribute that through dx. What are my integration points? Oh, boys and girls. Sine function, tell me anything about it. What's the period? 2 pi, so what's halfway in between? Pi, so where is this going to cross? Pi. Folks, look at x minus pi. Where is that going to cross the x-axis? Pi, right? So you can see how that works out. So those are my integration points. Great, we want to find the area. Let's do it. Antiderivative sign. Negative cosine. Antiderivative negative x. Negative x squared over 2 plus pi x. Evaluated at what spots? Pi and, okay, let's take this little by little. You might think that this looks ridiculous. No, this is the way they'll ask the problem, okay? I plug in pi. What's the cosine of pi? Negative 1, make it negative. Positive 1 minus pi squared over 2 plus pi squared minus, now what do we plug in? 0. What's the cosine of 0? 1. Make it negative. Negative 1 minus 0 plus 0. So you could write your answer simply as 1 minus negative 1 is 2 minus pi squared over 2 plus pi squared. That would suffice as an answer. My answer is written in terms of pi. That's fine. You might say, well, I want to find common denominators. Go ahead. You don't have to. Are we okay with that? Okay, move on to the next one. Right, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals negative pi. So have you seen this type of a question before? Yeah, we talked about this, right? We did this. You can see why I'm trying to set you up for these type of problems. Y equals negative pi. Where is that on my graph up here, folks? Yeah, it's this right here, right? Okay, so we're going to rotate the green stuff around there. What shape are you going to get? We are going to get a washer. So rotate that around. I can see my washer kind of shape. I'm going to draw my washer over here so I can figure this stuff out because I get confused unless I do this work. What makes up the middle? Y equals negative pi. Is this dx or dy? This is a dx thickness. Very good. It has horizontal width. And you guys are smart. What makes this inside part of my revolution? Is it g of x? And did we say that was y1 or y2? Well, it doesn't really matter because we don't get to use our calculator, do we? No. Okay. All right. And then the top one is f of x. Okay. So it looks like we have pi times big R squared minus little r squared. So what is your big radius? Is it f of x minus pi, or is it f of x plus pi? Very good. F of x plus pi. And my little radius? G of x plus pi. So can somebody tell me my integral expression? Pi integral. Good. F of x plus pi quantity squared. Dx, don't forget the dx, we'll take a point off. Bounds of integration. 0 to pi. Well, that's not too bad, is it? And there's not a calculation involved. They're simply just going to look at our resulting integral, right? So I think both of these are fairly gettable. Likelihood that you make a mistake on part A? Possible? Yeah, you're saying, okay, I might have made a mistake there, Mr. Gens. Okay, great. Thank you for your honesty. Let's do the last part for the day then. Region R is the base of a solid. For each solid at the x cross-section, perpendicular to the x-axis, is an isosceles right triangle where one of the legs lies in region R, right? But do not evaluate integral expression for the volume of that solid. Quick pair and share. Tell somebody what you know about an isosceles right triangle. Go. Okay, somebody tell me what you know about isosceles right triangle. Okay, it has a right angle. If it's isosceles, then two sides are the same. Now it says that one of the legs lies in the region. Sometimes it's the hypotenuse that lies in the region. The problem becomes significantly more challenging at that point. We can address that later. But one of the legs is in the region. So what is the length of the region? What's the length of the region? What's this length? Yeah, f minus g, right? So this is f minus g. So what's the other side of the triangle? F minus g, right? Do we need to know the hypotenuse? So this has thickness dx. What is the volume of that figure then? How do you figure out area of a triangle? 1/2 times base times height, which is the same thing, right? So we've got f of x minus g of x, that quantity squared dx. And we integrate from where to where? 0 to pi. Not bad, huh? Like, that's doable. Yeah. Those are excellent examples. This is spot on for the stuff that we need to know. We have 4 days this week. We'd like to cover 2 of these each day, and then I'd like to give you that as you head on home over your little break time. Give you some other time to fix it. But you can see what else we have coming on up. If we could just look real quick. You're not going to work on this, but we have motion, velocity, acceleration, particles slowing up, speeding up. You have other motion where you don't get a calculator. We have accumulation and arriving and departing. You've got a nice slope field problem. These are going to be the essential pieces. And if you want to do well on the tests I'm going to give you for this class, and again, I'm used to all sorts of things, and